Hey math kids, today we're going to talk about arc length and area of sector. But this time we're going to do it in radians. It's a little bit easier actually. So just as a quick review, if we have a sector or a portion of a circle like a piece of pizza, we have an angle that defines that sector as well as the radius, which is on both sides of this. And then we have S, which we're going to call the arc length. Now the formula for finding this is much more straightforward. It's just S equals R times theta. Now if we want it, once again this is arc length equals radius times the central angle. And then if we wanted to find the area, like the surface area of this piece of pizza or this sector, the area of sector is equal to 1/2 theta times R squared. Okay. So you're going to be given different pieces and you'll need to find different things. So if I find if my radius is given as 6 and my central angle is given as pi thirds, what is my arc length and what is my area of sector? Okay, so this one's pretty straightforward. I'm just going to plug in R and theta. This is R, this is theta. So I'm going to do 6 times pi thirds, and that's going to give me my arc length. If I multiply that out, it's 6 pi thirds, which is just 2 pi. And so that is my arc length. Feel free to turn it into a decimal if you prefer that. Okay, now the area of sector, I'm just going to plug it in here. So the area is 1/2 times the central angle, which is pi thirds, and then the radius squared. Okay, squaring that, we get 36. Multiplying everything, tops together, bottoms together, we get 36 pi over 6. 36 divided by 6 is 6, so that gives us 6 pi. Once again, turn that into a decimal if you'd like. Another thing to keep in mind though, arc length is going to be measured in something. So like if radius was in meters, this would be meters, but area would be meters squared. Okay, so even if you end up getting like the same number for your arc length and your area of sector, it's not claiming that they're the same thing because the units are different. Okay? All right. So let's try a new problem. Okay, this time we're given the radius to be 3, and let's say centimeters. We don't know the central angle. We're given the arc length to be pi thirds, and we don't know the area of sector, so we want to find those missing pieces. So I'm going to use the top equation to help me find the central angle. So we know the arc length is pi thirds. We know the radius is 3, but we do not know theta. So I'm going to divide both sides by 3, and dividing by 3 is the same as multiplying by 1/3. Multiply tops, multiply bottoms. I get pi over 9 equals theta. And so I write my answer right there. Now area of sector, I can just plug everything in. So I get 1/2 times pi over 9 times pi thirds squared. Okay? So if I square that, this is going to be a weird answer, but so if I square that, I get pi ninths, and then I get pi squared over 9. And so if I multiply the top together, I get pi cubed over, let's see, 9 times 9 is 81, so 162. So I could leave this as pi cubed over 162. That's a little crazy though. So I'm actually going to plug this one into a calculator, and my calculator doesn't work. So pi raised to the third, and then divide that by 162. And so the area of the sector is 0.1191. Once again, leave it like that or turn it into a decimal, whatever you want to do. Okay, and we're going to try one more. This time we're going to leave out the radius. So this one is pi thirds. The arc length is given as 3 pi halves, and we need to find the other two. So when we do that, we use the top equation. This time s is 3 pi halves. The radius is unknown, and the central angle is pi thirds. Since this is a fraction and I want to get rid of it, algebraically I'm going to multiply it by the reciprocal. Pi's cancel, we're left with 9/2. We multiply that out, so that's the radius, 9 halves. Area of sector, we just plug everything in, 1/2 times central angle times the radius squared. When we square a fraction, we square the top and square the bottom, so we get 81/4. Multiply all the tops, all the bottoms, we get 81 pi over 6 times 4, 24. We could definitely simplify that, but I'm just going to leave it and turn it in there. Feel free to, once again, plug that into a calculator. Feel free to simplify that fraction. I'm more concerned with, can you use the formula, though, than your simplification on this assignment. If you need additional help, please come to Math Lab. Until then, calculator.